So we are going to see what is force system, what are the different types of force systems, and what is the meaning of moment of force and couple. So let us see what is force. Force is defined as an external agency which tends to produce the motion in the body or changes the motion of the body or checks the motion of the body. That means tends to change the state of rest or motion of the body. So that is defined as force. Now see this picture. A boy is trying to kick the football. Initially, ball is at rest. So when he kicks, that means he has applied the force. The state of the ball is changed from rest to motion. So by applying force, he is producing the motion in the body which is at rest. At the other end, by applying force again, the ball which is in motion is stopped by applying the force in the opposite direction. That means he checks the motion of the body. Suppose if the ball is moving with some velocity and some force is applied, the acceleration of the body is changing. Means the state of motion of the body is changing, right? So the force is the agency which tends to produce motion or checks the motion or changes the motion of the body. In order to define the force completely, you must know its 4 characteristics. So these characteristics are also known as specifications of a force. So in order to define a force completely, you must know its magnitude, direction of force, point of application of force, and the sense. Sense of force means whether the force is acting away from the point of application, whether it is trying to pull the body, or whether it is acting towards the point of application. That means it is tending to push the body. The pull or push is nothing but the sense of the force. See this figure. A force of 30 newtons is acting at point A at an angle 45 degrees with respect to positive x-axis, and it is acting away from the point. That is the complete description of the force. So what is the magnitude of the force? 30 newtons. It is the amount of force which is measured in Newton in SI unit. So the magnitude of force is 30 newtons. Direction. So how do you define the direction of force? It is defined as the direction of line along which the force tends to move the body. So that line is nothing but line of action of force. So the direction of force is defined as the direction of line of action of force. What is line of action of force? It is the line in which the force tends to move the body. So here, what is the direction? It is 45 degrees with respect to positive x-axis. Now, point of application. So yesterday we have seen that this point of application is an idealized concept. So we are assuming that the entire force is concentrated or acting at a particular point, which is known as point of application. So in this particular case, point of application is A. So it is acting at point A on the body. Then sense. So here, see the arrowhead of the force. It is acting away from point A. So the sense of the force, here it is pull. Means this force is trying to pull the body in the direction of line of action of the force. Right? It is pulling the body. So that is the sense of force. Now, if the arrowhead is acting towards the point A, so it is pushing the body. So here the sense of the force is push. So the direction of arrowhead will define the sense of the force. So these characteristics are also known as specifications of force. Is it clear? So the magnitude, direction, point of application, and sense. Simply, magnitude is the amount of force acting on the body measured in Newton. Direction is the direction of a line, direction of straight line, in which the force tends to move the body with respect to any reference axis. Point of application, it is the point at which the force is assumed to act. Sense, it depends on the direction of the arrowhead, whether it is a pull or push, depending on whether the force is acting away from the point of application or towards the point of application. So what do you mean by force system? If number of forces are acting on a body or at a point, then the combination of all those forces, the collection or group of all those forces is known as force system, right? Force system is nothing but the group of all forces acting on the body. The two bodies are there. One is having with considerable dimensions, other one is say particle, and four forces are acting on this body: F1, F2, F3, and F4. Now we can say that this body is subjected to a system of forces having four forces. Now, what are the different types of force systems? So in engineering, basically, there are four types of force systems: coplanar and non-coplanar force system, concurrent and non-concurrent force system, parallel and non-parallel force system, and collinear and non-collinear force system. And then there is a combination of these four basic force systems like coplanar, non-concurrent, coplanar, concurrent, coplanar, parallel, coplanar, non-parallel, and so on. So that we are going to see in detail. So in brief, coplanar force system means all the forces are acting in the same plane. In any plane, all the forces are acting in the same plane, that is coplanar force system, if not non-coplanar force system. Concurrent force system, if the lines of action of all forces are passing through a common point, that is concurrent force system, if not non-concurrent force system. Parallel, if the lines of action of all forces are parallel to each other, then that is parallel force system, if not non-parallel force system. Collinear, if the lines of action of all forces are acting along the same line, the lines of action of all forces are acting along the same line, that is collinear force system, if not non-collinear force system. So let us see in detail coplanar and non-coplanar force system. The definition: if two or more forces are acting in the same plane, then the system is known as coplanar force system. If forces are acting in different planes, then the system is known as non-coplanar force system. Now see here, there are three coordinate axes, X, Y, and Z. Say this origin O represents the corner of the room. Assume that it is the corner of the room. Now here, XZ is the horizontal plane of the room. Now this XY is the vertical plane. Similarly, YZ is the vertical plane of that particular room. So here we have three different planes, two vertical planes and one horizontal plane. Now I have shown three forces, P1, P2, and P3, acting in the horizontal plane XZ. So all these forces are acting in the same plane, that is XZ plane. So I can call this group of forces as a system of coplanar force system. Is it clear? All forces are acting in the same plane. Similarly, there is one more system having 4 forces, Q1, Q2, Q3, Q4. Of course, they are passing through a point, but all these 4 forces are acting in the same plane, that is XY plane. I can also call this system as coplanar force system. Now this photo frame is hanging from the nail A. Let T1 and T2 be the tensions in the string attached to this photo frame. Now I can call that this T1, T2 forms a system of coplanar concurrent force system. Am I right? Because this T1, T2 are acting in the same plane, that is YZ plane. So again, this is known as a coplanar force system.
Excuse me, sir.
Yes.
Sir, for coplanar force system, can we say that the force system in which line of action of force lies in same plane?
Exactly. Because if the forces are acting in the same plane, means the line of action of those forces by default, they are also in the same plane. So now there is a pole, say OC, which is held by 3 ropes, say CD, CE, and CF. So this post is held by 3 ropes which are in 3 different planes. Let the tension in these ropes be F1, F2, F3. Now it is a force system having 3 forces, F1, F2, F3. But F1 is acting in a YZ plane, right? It is acting along the line of action, say CD. So it is in YZ plane. And F2 is acting in some other plane, which is not defined over here. Whereas F3 is acting in XY plane, right? So all these 3 forces are acting in 3 different planes. So we can say that this system is non-coplanar force system. Here the lines of action of these forces are acting in different planes. Then concurrent and non-concurrent force system. So if the lines of action of 2 or more forces are passing through a common point, then that system is known as concurrent force system. If the lines of action of all the forces acting on the body not passing through a common point, then the system is known as non-concurrent force system. Now let us consider a small body on which 4 forces are acting, F1, F2, F3, F4. But the lines of action of all these 4 forces are passing through point O, which is common. So this system is known as concurrent force system. Now here, again 4 forces are acting on the body, but the lines of action of all these 4 forces are not passing through a common point. So it is non-concurrent force system. Parallel and non-parallel force system. If the lines of action of all forces are parallel to each other, then that system is known as parallel force system. If the lines of action of all forces are not parallel to each other, then that system is known as non-parallel force system. Now see here, a body is subjected to a system of 4 forces, but the lines of action of all these 4 forces are parallel to each other. So it is known as parallel force system. Here, the lines of action are not parallel to each other, so it is non-parallel force system. Again, in a parallel force system, there are 2 types, like parallel force system and unlike parallel force system. In a like parallel force system, all the forces, the sense of all the parallel forces are having the same direction. For example, now let us consider this body. Say force P1 is acting downwards, P2 is acting downwards, also P3 is acting downwards. Now the lines of action of all these forces are parallel to each other. So it is a system of parallel forces. But the sense of all these three forces is same. So you can call this system as like parallel force system. Okay. So if the lines of action of all the forces are parallel to each other, but the sense is opposite. For example, here P4, it is acting upwards. Now four forces are acting. The lines of action of all forces are parallel to each other. So it is parallel force system. But the sense of these forces are opposite. They are not having the same sense. So you can call this type of system as unlike parallel force system. Then collinear and a non-collinear force system. So collinear force system and a non-collinear force system. If all forces are acting along the same line of action, then it is known as collinear force system. If the forces are acting along the different lines of action, then the system is known as non-collinear force system. Now see here, there are 6 forces are acting, F1 to F6. But the line of action of each and every force is same. All forces are acting along the same line. So the line of action of forces is same. You can call this system as a system of collinear forces. The best example is tug of war. So group of people pulling the rope from both sides in opposite direction by applying forces along the rope. That rope is acting as the line of action of all the forces, right? So it is collinear force system. Non-collinear, that means the lines of action are different, whether it is a concurrent force system or parallel force system. Here the lines of action are different for different forces. So it is non-collinear force system. Then combination of force systems. Types of force systems are 4. Coplanar, non-coplanar, concurrent, non-concurrent, parallel, non-parallel, and collinear, non-collinear. Now there is a combination. So the coplanar concurrent forces are acting in the same plane and passing through the common point. Say this system, Q1, Q2, Q3, Q4. All these 4 forces are acting in the same plane XY. So it is coplanar force system. At the same time, the lines of action of these forces are passing through a common point. So it is concurrent force system. You can say this as coplanar concurrent force system. Now coplanar non-concurrent. Here P1, P2, P3. They are acting in the same plane. It is a coplanar system, but the lines of action are not passing through a common point. So it is coplanar non-concurrent force system. Then coplanar parallel means lying in the same plane but parallel to each other. So all these 4 forces are acting in the plane YZ, coplanar. At the same time, the lines of action are parallel to each other. Then coplanar non-parallel. You can consider this P1, P2, P3 or Q1, Q2, Q3, Q4. These 2 systems are coplanar non-parallel. acting in the same plane, but lines of action are not parallel to each other. Similarly, non-coplanar concurrent means forces are acting in different planes, but passing through a common point. So this is the best example. Forces F1, F2, F3, they are acting in different planes. So it is non-coplanar force system, but the lines of action of all these forces are passing through point C. So it is a concurrent, non-coplanar concurrent force system. Now, non-coplanar, non-parallel, you can consider the same example, right? These are non-coplanar force system, but the lines of action are also not parallel to each other. So hence it is non-coplanar, non-parallel. Now, non-coplanar, non-concurrent. See here, F1, F2, F3, F4. 4 forces are acting total. I am considering these 4 together as a system. But 2 forces are acting in YZ plane, 2 forces are acting in XY plane. So it is non-coplanar force system. But the lines of action also not passing through a common point. So it is non-concurrent force system. Are you following me? So it is non-coplanar, non-concurrent. Now non-coplanar parallel. I can consider the same system as non-coplanar acting in different planes, and the lines of action are parallel to each other. So I can call this as non-coplanar parallel force system. So if you have any doubt, you please ask. Now, the most interesting part, that is moment of force.
Excuse me, sir.
Yes.
Sir, how can be a non-coplanar forces can be a parallel to each other, sir? They should lie in the same plane, then we can say they are parallel.
Not necessarily. Na? Suppose you consider a table. Table is having 4 legs. So the weight of table is transferred to the ground through 4 legs, right? So if you consider the forces in 4 legs as a system of forces, all 4 legs are not in the same plane.
So skew forces.
Yes. See, out of these 4 forces, 2 forces are in one plane and 2 forces in other plane. Even this figure also, here F1, F2, they are in YZ plane, and F3, F4, they are in XY plane. They are in different planes, but all are parallel to each other. Is it clear?
Okay, sir.
The moment of force. The effect of force on the body is twofold. Means when a force is applied on the body undergoes, it may undergo 2 types of motion. One is it may tend to move from one place to the other, means having translation. At the same time, the body tends to rotate about some arbitrary point. That means it may have rotation also. So the effect of force on the body is to produce either translation or rotation or both. Is it clear? For example, let us consider this body which is kept on the surface, horizontal surface. G is the center of gravity of the body. Now I am applying force F on the body such that the line of action of this force is passing through the center of gravity. Now, what is the effect of this force on the body? To produce translation. Being the line of action is passing through the center of gravity, there is no question of rotation. The body cannot rotate because the force is applied at its center. Is it clear? So it may have only translation. But if the force is applied at a point such that the line of action is not passing through the center of gravity. Now, what is the effect of this force on the body? It tends to rotate the body about some arbitrary point. So it is producing the rotation. If the center of gravity is fixed, if the body is fixed to the floor at G, then the body will have only rotation if you apply force at the corner. Please listen carefully. If the body is fixed to the floor at its center of gravity, when you apply force at the corner, the body undergoes only rotation. But if G is not fixed to the floor, it is just kept on the horizontal floor and force is applied at the corner, then you will observe that the body will have translation as well as rotation. When you can say that the body is having translation, if the position of center of gravity of the body changes, then you can say that it is having translation. So it is changing its position from one place to other. But the position of G remains same. It is rotating about G. Then you can say that the body is having purely rotation. Because the position of center of gravity is not changing, means it is not undergoing any translation. So it is having only rotation. Are you getting my point? So when a body is kept on the surface, you have applied the force, then the body may change its position, means the position of center of gravity may change. At the same time, the body tends to rotate about an arbitrary point. Means the effect of force on the body is twofold, to produce translation and rotation. This rotational effect produced by the force on the body is known as moment of force. The turning effect or rotational effect produced by the force on the body is known as moment of force. Understood?
Sir,
Yes.
so it should be only rotational effect and not rotational and translational, right?
See, if the position of center of gravity is fixed, then the force will have only rotational effect on the body because G is not changing. For example, you are opening the door. So the door shutter that is hinged to the door frame, right? The hinge is the connection. It is fixed. So when you push the door will rotate about the hinge. There, the effect of force on the body is to produce only rotation. Is it clear? That rotational effect
Yes,
produced
sir.
by the force is known as moment of force. Because of that moment of force, only you are able to rotate the door. Suppose if that G is not fixed, simply body is kept on the surface and you apply force at the corner, then the body may displace. It may change its position from one place to other. Means the G may change its position. At the same time, it may rotate. Is it clear? That means the moment the position of center of gravity changes, you can say that the body is having translation. As the body is tending to rotate about some arbitrary point, you can also say that the body is having rotation. So the effect of force on the body is to produce translation and rotation. And this rotational effect or turning effect produced by the force on the body is known as moment of force. Right? Now, we'll see some important points related to the moment of force. Moment of force about a point is calculated by taking the product of magnitude of force and the perpendicular distance from the line of action of the force to the point about which the moment is to be taken. The product of magnitude of force and perpendicular distance from the line of action of the force to the point about which moment is to be taken. So we'll take one example to understand it better. So moment of force M is equal to F into D. What is F? Magnitude of force. What is D? D is the perpendicular distance from the line of action of force to the point. It is not simply the distance between the point of application of force and the point about which moment is to be taken. It is the perpendicular distance from the line of action. So depending on the sense of rotation of the body, the moment of force can be a clockwise moment or anti-clockwise moment. So the force is tending to rotate the body in clockwise direction. You can say that the sense of moment of that force is clockwise, or if the body is tending to rotate in anti-clockwise, then you can see that the sense of moment is anti-clockwise. In our study, we are going to follow this sign convention. All anti-clockwise moments are taken as positive and clockwise moments
Sir.
are taken as negative. Yes. Now here, let us consider a body of length 2 meters. A force of 50 Newton is acting at point B at an angle 45 degrees with respect to horizontal. Now, I want to find out the moment of this force 50 Newton, which is acting at B, about point A. So I want to find out the moment of the force about point A. So moment about point A is equal to simply to the product of magnitude of force into D. What is D? It is not the distance between the point of application of force and point A. It is not 2 meters. D is the perpendicular distance from the line of action of the force to point A. And what is the sense of this moment of force about point A? If you observe this, the force is tending to rotate the body in clockwise direction. So the moment center is point A. The force is acting here. Now the force is tending to rotate the body in clockwise direction. So the sense of moment is clockwise. Now it is the line of action. We are drawing perpendicular from point A. Say D is the perpendicular distance. So in this F into D, here D is this perpendicular distance from the line of action of the force. So from the triangle, right angle triangle, A, B, C, we have sine 45 is equal to opposite side D by hypotenuse 2. So that gives you D is equal to 2 sine 45. Then moment about A is equal to, see here, I am writing minus. Why? Because the sense of this moment created by this force about point A is clockwise. As per our sign convention, clockwise moments are taken as negative. So it is minus. Force, magnitude of force is 50 into D is the perpendicular distance, that is 2 sine 45. That gives you minus 70.71 Newton meter. So the magnitude of moment is 70.71 Newton meter and sense of the moment is clockwise, being it is minus. So the point about which moment is taken, that is here A, is known as moment center, and the perpendicular distance D is known as moment R. This D is known as moment R. Now the moment of force about a point is 0. When it will be 0? The moment of force about a particular point is 0. Under which condition? Anybody?
Sir, when D will be 0?
Exactly.
When
When
the
D
point
is
lying on line of action of force.
right. So when D is
When
0
point
means the line of action of the force is passing through point A. That means if the force is acting at A, the line of action is passing through A, then the perpendicular distance becomes 0 as moment is equal to F into D, being D is 0, the moment is 0. So moment of force is 0 if the line of action of the force is passing through the point about which the moment is to be taken. So here it is said. Then couple. See here, couple. So do you have any idea about couple? Couple means what? Pair. Pair of two.
Sir, it's a pair of forces which are acting opposite to each other, such that there is a no translational motion, but they produces the moment of force
Very good.
in same direction.
Right. So couple is defined as two equal and opposite parallel forces. See, when two equal and opposite parallel forces are acting on a body, you can say that those forces are forming a couple. Two equal magnitudes are equal, opposite sense is opposite, and parallel. The lines of action of those forces are parallel to each other. For example, let us consider 2 points A and B on a body. The two forces of magnitude F are acting at A and B, but the lines of action of those forces are parallel to each other, but the sense of the force is opposite. So two equal and opposite parallel forces are said to form a couple. Now, what is the effect of these two forces on the body? Say D is the perpendicular distance between the two lines of action. The effect of these two forces on the body is to produce rotation only. Body cannot move from one place to the other. Means the position of G is not going to change, but it can only rotate at the same position. That we will see in detail to understand that concept. Effect of couple on the body is to produce rotation, and the rotational effect produced by the couple on the body is known as moment of couple. So what do you mean by moment of couple? It is the rotational effect produced by the couple on the body. And moment of couple is equal to force into perpendicular distance between the lines of action of two forces. See, here the basic difference between moment of force and moment of couple. See, the moment of force, again it is force into perpendicular distance from the line of action of the force to the point, but the magnitude of moment of force depends on the distance from the line of action of the force to the point. If the moment center is changing, the perpendicular distance between the line of action of the force and the point is changing, then the magnitude of moment is also changing. Am I right? But in case of couple, the moment of couple remains constant. That we will see by taking one example. So moment of couple is equal to F into D. Here what is F? The magnitude of the force, any one of the force constituting the couple. And what is D? Perpendicular distance between the two parallel forces. And moment of couple can be clockwise or anti-clockwise depending on the rotation of the body, whether the couple is tending to rotate the body in clockwise or anti-clockwise direction. So anti-clockwise couple is taken as positive and clockwise couple is taken as negative. The SI unit is same as the moment of force. It is Newton meter. So the characteristics of couple. So this we are going to study in detail to understand the concept of couple in the next class.